It's time to get to the fun of making sawdust. The first operation will be cutting all the boards for the drawers. I made a jig for cutting across the 4-foot side of the plywood, but I never made one for the longer side. I already have the first sheet ready and spaced up off the table using scrap 2x4s. I have one at each corner of the sheet and 3 along both sides to keep it as flat as necessary. Here I am setting up the jig for the first cut of the drawer sides. I measure multiple times at each end to be sure the jig is both the correct distance and parallel to the edge of the sheet. The edge of the jig will be the measurement of the board to be cut plus the kerf of the blade. This first cut represents 3 boards which will be finished on the table saw. I always use a small hammer to dink the jig for small adjustments. Using the hammer, I am tapping to move it about 1/32 of an inch. And here I am labeling the name of the part so I know what they are after finish cutting. Now we're ready to grab the saw and carefully run it down the jig. I have the blade depth set at about 1/8 inch below the sheet. The first cut of many is completed, and now to reposition the jig for the next cut. Now I have the sheet moved up and ready along with my plans and cut sheet in front of me to avoid errors. This is just a repeat of the previous cut, but watch as I F it up while thinking about the video instead of the job. Did you see it? What a dumb move. The saw was on the cut edge of the jig, not on the guide edge. This is a huge error, but I am lucky I caught it before completing the cut. I finished the cut in the correct location, and you will see later I did this 3 more times while not paying attention. Later you will see what I did to recover from these errors and avoided having to buy another sheet of plywood. Now setting up for the third cut on the same sheet. After setting the jig, I am inspecting and comparing it to the print and found that it was wrong. This is why I always have a print in front of me. The cut sheets I have at the start are not the same layouts as the finished design. I went back to the design and was able to rearrange the cut sheet layouts to save material. Now that it is down to less than half a sheet, it is small enough to handle on the table saw. Now I have the table saw positioned and ready to go. I use my magnetic angle guide to ensure the blade is at 90 degrees, and then double checking the fence setting with the print. Last, I am confirming the blade height. Most of the time I prefer about 1 tooth extending above the board. Stop right here and look what I forgot to do. Sighting along the fence, you can see 2 scraps of 2x4s in the path of the board. These are small enough not to be an issue. This time. After the cut, I wait until I can count the teeth on the blade before moving the board that is still close to the blade. I had an incident where I tried to move a board too soon and it was shot across the shop when it contacted the still rotating blade. Now that I have all of the long cuts for the drawers complete, I will finish up using my Crosscut Sled. If you do not have a Crosscut Sled, you have no idea how bad you need one. There are many instructional videos showing how to make them. When I first saw one of these videos, I thought it was interesting, so decided to build one, having no idea how useful it would be. For the front and back, I used 2 pieces of 3/4 plywood laminated together for 1.5 inch thick boards. I glued them to 1/2 inch thick MDF base, although most use 3/4. I used 1/2 thick to cut down on the weight, and it's been holding up well now for 3 years. The counterbore screws seen in the base go through to the miter slot guides. After the initial saw cut is made, it is a simple thing to line up a cut mark on a board to the slot in the front push plate to make the cut. When cutting multiple pieces of the same length, it is easy to clamp stops right onto the push plate. Looking at the bottom, you can see the 2 miter guides out of 3/4 by 1/4 maple. Now ready to cut on the sled, and since I will be cutting multiple boards the same size, I have a stop clamped to the table extension since it overhangs the sled. If I ever make a new sled, I will make it the same size as the table. Slide the board gently to the stop and make sure the board is against the front and there is no debris such as sawdust in the way, as this will change the angle of the cut. Turn the saw on, then push the sled to make the cut. I have considered adding a blade guard and stop on the back to eliminate the hazard when the blade is exposed at the end of the cut. Now slide the board over and perform the second cut. Now time to go and cut the rest of the boards. All the boards for the drawers are cut, and now it is time to repair the 3 mistakes because I am just too cheap to go out and buy another sheet of plywood. Here are the 3 boards needing the repairs. I started to cut at the wrong point, thinking more about this video than the job. I could scrap them and spend another $80 on a sheet of plywood, finish the cuts and edge glue another piece, but that would introduce a weak joint. Or I think I will experiment with some shims to slide into the gaps. I pulled out my new bandsaw to cut the shims. I need to do some reorganizing in the shop before deciding where it will be mounted. Then need to build another stand similar to my drill press stand, except this one will need to be mobile. How big is that gap in the first board to be repaired? Well, I actually know what it is, but wanted to show my 3D printed gap measuring tool. Inserting the tool into the gap shows that it is 1/8 inch, which is the kerf of the blade on the table saw. I know you can buy these tools, but you forget. I am cheap, and that might have cost me maybe 20 cents worth of plastic. One of only 2 complaints about this saw so far is that it has a small miter slot, so my standard feather board does not fit. I will have to cheat using a handheld board to keep the piece against the fence. While holding the piece against the fence with one stick and pushing with another, I have my first test shim, and now I need to check the fit. Not bad for first cut. It is just a bit tight, and after a little sanding, I'm sure it will be a perfect fit. Now setting up for the 2 thinner shims. Here is the first test cut for the smaller kerf that has to be filled. This was way too thick, and I will have to readjust for a thinner cut. The tape measure guide is my other complaint for this saw. It is just a bit off, so I cannot use it for accurate cuts. I am using my calibrated eye to set it a bit thinner. Here is test cut 2, and a close-up, you have to admit that's not a bad cut for a low-end bandsaw. This would be a 5-star saw except for the skinny miter slot and non-adjustable tape measure. This one was just a bit too thin, and I need a tapping adjustment. The last test cut was still too thin by a few thousandths, so a bit more tapping, and I'm going to go for the full-length shim. Scrounging through my cutoffs, I came up with a pine board long enough for the other 2 repairs, and now cutting one of the full-length shims based on the last test cut. It was just a bit too thick for a slip fit, so I got my simple sanding block with 150 grit sandpaper glued on using spray adhesive. I always have one of these lying around. These need to be a slip fit with no play and just a bit of sanding made for the perfect fit. Now to cut another shim for the last board and move on to the glue up for the repairs. I will be using expanding polyurethane glue for the repairs. The polyurethane glue is not so easy to clean up, so I glove up for any jobs that require me to touch the surfaces that have glue applied to them. I have a couple of blocks clamped to the board with C-clamps that I will use to spread the gaps so I can easily insert a shim. Using a bar clamp reconfigured as a spreader, I put it between the blocks to open up the gap, allowing me to easily slide the shim into place. First test fit of the shim, I found some interference at the far end. After a little head scratching, it dawned on me that the interference was material left over from the circular saw blade. I decided the easiest thing to do would be to sand an arc into the shim matching the arc of the saw blade. Now that I have the arc cut into the shim, it easily slides right into place. This type of adhesive cures with moisture, so it is recommended to spray water on the side of the joint that does not have the adhesive. I have a small spray bottle spraying the gap with water. It was a cold day and the glue was very stiff and hard to squeeze out. For the second repair, I set the bottle in hot water to thin it out a bit. I spread a thin layer of glue on both sides of the shim, then placed it in the gap, then removed the spreader and other clamps and blocks. I put a flat vise clamp on the open end to be sure the two ends stay in the same plane. That clamp will be removed after the glue is set, but before it is cured. Tapping the shim down with a hammer to make sure it is flush on the side that is against the bench. Then added one bar clamp to ensure the expanding glue does not spread out the joint. This is the first repair after the glue was fully cured, showing how it has expanded out of the joint. Parts need to be clamped or weighted because as the glue expands, it can push the parts apart. With a clamp in place, the glue is forced to expand throughout the joint instead of pushing the parts away from each other. This type of glue works by expanding into every tiny little crevice in the objects being joined, and why it has high strength. Many people complain about this type of glue only because not understanding the expansion, and in most cases too much is applied. In future projects you will see how I protect the grain from being contaminated with the glue when the project will be stained. The squeeze out is easily removed with a sharp chisel, but this chisel needs a little touch up on the grinder. After sanding and paint, nobody will know of my errors. For the second repair, I moved the spreader to the bottom, getting it out of my way. There was no reason for it to be on top of the board. The shim is already sanded to fit the arc at the end of the gap. I also spaced it up off the bench with some scrap boards under the gap to keep it aligned with the other side. The glue came out of the bottle and spread much easier after it was warmed in the hot water, but when doing that, must be careful not to contaminate the bottle with moisture or it will start to cure in the bottle. I repaired board 3 using the same method, and now all boards are ready for machining in the next part of this series.